And this is very first presentation session on social networking and friendships. So there will be four talks, and each talk will have about 20 minutes, and then we have 5 minutes for question and answers. So we are about 5 minutes late. The first talk will be given by Lujun Fang.
So good afternoon, everyone. I'm Lujun Fang from University of Michigan, and I'm very glad to present our paper, Look Who I Found, Understanding the Effects of Sharing Curated Groups. This work is co-authored with Alex Fabricant and Kristen Lefevre from Google Research. So social network sites like Google Plus and Facebook attract hundreds of millions of users. And users get involved in these social networks by first get connected to other users. And for the purpose of information sharing and consumption, users usually put their contents or friends into groups. For example, I can have my friends and family into separate groups called friends and family. And I can have a user group called chess club to include all my friends know from a chess club and whoever they are on the social networking site to this chess club user group. And I can even connect with those celebrities online. For example, I can follow my favorite NBA players on Google Plus and putting them into a separate user group. So Google Plus provide this functionality called circle sharing. So in Google Plus words, a user group is called a circle. So I can click one of my circles and click the circle sharing button. Now other users could see that I have such a user group and such a circle, and other users could add the members in the circle to their own circles. So this is a screenshot that I click one of my circles and try to share it to other users. So I can see who is in this particular circle. Then I can choose to whom I want to share this circle to. So I can share it to public to everyone, or I can specify like which specific group of person or which individual person I want to share this circle to. So my friend Lee, upon seeing I'm sharing the circle, he can actually click that, and then he can decide, he can see who is inside the circle I shared. Then he can decide either to create a new circle to putting these members in the shared circle, or they can put those members to an existing circle he already have. So with this circle sharing feature available, and with a lot of users using this feature, so there are a lot of interesting research questions we can ask. And the first question we want to ask, of course, is that what is the impact of this circle sharing feature on the structure and the growth of this Google Plus social network? And to best understand this question, we would also like to know that is there different types of shared circles, and how can we identify them? And with understanding of these two questions, we would also like to know that can we recommend to users which of their circles are suitable to be shared? So we are going to answer all these questions by performing large-scale data-driven examinations. These examinations will be based on a large sample of Google Plus circles, and they will be based on mostly on the circle's topological structures. So essentially, in the data, what we have is for a lot of circles, and for each circle, we know how the topological structures associated with those circle members. We know how they are connected to each other, and we know that how they are connected to the circle owner, and how they are connected to other users outside the circle. So we will perform 3 analysis mapping back to the 3 research questions we have. So we are starting by perform analysis, trying to understanding how we can categorize the shared circles. And then we are trying to understand the impact of circle sharing. Then we will perform analysis to see if we can recommend which circles to be shared. So we'll start with this analysis of categorization of shared circles. So the way we understand this is first get a sample of those shared circles, mixing them together, and we try to extract features from those circles. So circle now can be represented as feature vectors. Then we can perform clustering analysis to see if there are similar circles that are very similar to each other, so whether we can find those clusters of circles. So remember that our features will be extracted from the topological structure of circle and their members. So the first feature we consider is reciprocity. So on Google+, the connection between users can be symmetric or asymmetric. So if I add my friends in the chess club, most likely they'll follow me back. So our connection is symmetric. But if I follow an NBA player, most likely they will not follow me back. So the connection is asymmetric. So the reciprocity feature here for Circle is trying to capture the proportion of the Circle members who actually follow back the Circle owner. The next feature we consider is the density of Circle. So Circle members can be connected to each other, or they might, in other cases, not connect to each other. So the density here of a circle here is defined as the number of existing bidirectional edges between circle members divided by the maximum possible number of bidirectional edges. We also consider a feature called popularity. So each user on Google+ can be followed by other users. And we call the number of followers the user have defined as the popularity of user. And we define the popularity of Circle as the median popularity of the Circle members. Notice that we use the median popularity instead of mean popularity because this value of popularity of a particular user is very skewed. For example, if you have Lady Gaga in one circle, she'll have millions of followers, and computing the mean doesn't make any sense here. So we are using the median popularity of circle members as the popularity of a circle. So based on this feature extracted from the topological structure of the circle, then we have those circles represented as feature vectors. Then we can perform the clustering analysis. So we use k-means clustering algorithms. And before performing the clustering algorithm, there are two pre-processing steps. First, we need to apply a scale function to make sure that the features are normal, feature values are normalized, and no single feature dominates the clustering results. Then for k-means, we needed to decide what's the right value for k. So one way of deciding k is just trying to plot the within cluster sum of square trending plot and trying to observe the need in the plot. In this case, we observe that k equals 4 is a good value. So based on the scaled features and based on k equals 4, we perform the k-means clustering, and then we get a 4 clusters of shared circles, and each group of bar plot here actually represents a cluster of shared circles, their characteristics. So the color here is not very clear, but on the left, for each group of circles on the left, it's the reciprocity feature. And in the middle, it's the density feature. And on the right, the black one is the popularity feature. So what we notice here is for the first two classes of shared circles, we notice that they are of high reciprocity and low popularity. So this reminds us of those circles like my chess club, where I'm adding my friend. I'm adding my friend to in the chess club to this circle, and most likely they will follow me back. So this circle has high reciprocity, and they are ordinary people, so they will probably have 100 to 200 followers. So they have relatively low popularity, and they might already connect. They know each other, and they might already connect to each other on Google+. So they might have high density, but in other cases, they might just join this Google+ social network. And in some cases, this kind of circles can be a bit low density. So in either case, this reminds us of those real-life communities. So we call these two classes of circle community circles. So then we look at the two class circles on the right. So we notice that these circles are of low reciprocity and high popularity. So this reminds us of circle like the NBA player circle I have. So they are famous people, they have high popularity, but most likely they are not following me back. So they have low reciprocity, and some of them may connect to each other. They might have reasonable density, but in other cases, they might not as dense as the community circle we have. So because they represent those celebrities, so we call this class of circles celebrity circles. So we have seen these two categories of shared circles. Then we can try to answer the next question: how can we understand the impact of circle sharing? So there's two major questions about impact we're asking. So first is that does circle sharing accelerate the densification rate of those community circles? And does exposure to circle sharing, for example, being the recipient of a shared circle, accelerate the rate at which a user adds others to his or her circles? So the way we answer both questions is that we first group circles into cohorts according to the weeks they first time getting affected by circle sharing. So for different questions, so its effect is defined a bit different. For the density case, it will be the week that the circle is first time get shared. And for each such cohort, then we can compute the value for a matrix, for example, the value of density over time. Then we can observe the value increase over time and comparing the value increase rate before and after circle sharing week to see the impact of circle sharing. So let's look at an example of understanding the impact of circle sharing on circle density. So the x-axis here is time from September to December, and I have two dashed lines here representing one specific cohort of circles we are showing here. It's from those circles first shared during November 2nd to November 9th. And then for this cohort of circles, we compute the mean density of among the members over time. And so this is the dot here. And then we can observe the slope of this trending line, and the slope essentially represents the increase rate, and compare it before and after circle sharing. So we have the slope before circle sharing at the blue line here, and the slope after circle sharing, the red line here. So we can see that the slope becomes steeper specifically during the circle sharing week. So indicating that when the circle gets shared, the increase rate increases a lot for those shared circles. And this indicates the speed change of the circle density increase. And we also want to know whether there are structural changes affect the circle members. So the answer is actually yes. So the way we look at this question is we pick the circle members and divided them based on the different degree, essentially the bidirectional edges they have with other users before the circle sharing event. And we observe for circle members of different degree, what's the percentage of the increase rate of their bidirectional edges during the circle sharing week. We notice that those users with small degree increase a lot during circle sharing week, while those users with large degree increase only a little bit comparing to those with small degree user. So this is indicating that this circle sharing feature helps a lot for those new users where they typically difficult to find new friends to add. So this is impact have great impact on them. And the other impact question we have is about another user exposed to a shared circle after he seeing the shared circle, what he does. So here we have the metrics measuring for the user seeing a shared circle, we measure the change of the number of circles they have over time. And for a fixed set of circles, the average size of those circles they have. And we notice that for both metrics, so the increase rate during circle sharing week changes a lot. And this again indicates the impact of this circle sharing on those users who sees those shared circles. So, so with the understanding of the impact of shared circles, finally we want to ask that for social network sites, whether they can recommend to the user which circles to be shared with friends. So to recommend which circles to share, essentially what we want to know is what's the difference between those shared circles and those circles are not shared. So the way we define circles not shared here is that circles not shared, but their circle owner has shared at least one circle. So the circle owner actually knows this circle sharing feature. So we look at the different feature we have and looking at what is different for the value distribution for these different features for those shared and non-shared circles. So here we draw the probability density distribution for the reciprocity, and the black line here are for shared circles, and the dashed right line here are for non-shared circles. And we see that for both type of circles, they both exhibit this kind of bimodal distribution where circles tend to be extremely high reciprocity or low reciprocity. And another interesting thing to notice that this behavior is more extreme for shared circles. So this could be one evidence that we can compare the difference between shared and non-shared circles. That if we see a circle with extremely high or low reciprocity, it could be more likely they are shared circles. So we do a similar comparison for density and popularity. So when we look at the distribution, we notice the difference. And we notice that those shared circles that tend to be have a higher density and have higher popularity. So we also want to ask that aside of these features, is there any other features we can consider? So one question a user before sharing a circle, he might ask is that when sharing this circle, is this circle useful to other users? So this is actually hard to predict because this happens after you share a circle. But one thing we can measure is to what degree have other users created similar circles, and maybe we can use that as an indication of the usefulness after we share the circle. So this the way we measure this kind of commonality and the way we measure the similarity to other circles is that for a circle, for any pair of users inside, what is the conditional probability that for another circle have one of users, the circle will also have the other user. So by computing this conditional probability, we'll get a good sense of how other users have created circles in a similar way. So we also draw the probability density distribution for shared and non-shared circle according to this commonality feature. And here we notice there's a great difference between the shared and non-shared circles according to this commonality feature. And we notice that those shared circles are in general more common. So based on these four features, we can then try to perform classification to see if this kind of recognition is possible. The way we do is perform mixing the shared circle and non-shared circle together, then perform classification by holding out the 2/3 of circles for training and using the remaining 1/3 of testing. So what we see here is that those shared circles can be predicted more accurately compared to the baseline where we make a random guess. And the sharing of complete circles can be predicted more accurately than predicting of those elliptic circles. So this is essentially the analysis we've done. And as a conclusion, so we've identified two main categories of shared circles, the community circle and the celebrity circle. And we understand the impact of shared circles. We see that circle densification rate gets increased during the circle sharing week. And we see that the users who exposed to the shared circles are adding new friends into the existing circle or adding new circles at a faster rate. And we also demonstrate the feasibility of suggesting to a user which circles should be shared with friends. So this is end of talk, and thanks, and welcome for questions.